Bom dia, pessoal. Hoje a gente vai ter um assunto super interessante no Lab Training, que é a introdução ao Git, ao GitHub. Eu confesso que eu estava super empolgada para esse dia chegar, porque eu sou um zero à esquerda em relação a isso, e eu acho que para a gente que trabalha com bioinfo, com biologia computacional, biologia de sistema, é super importante a gente ter um controle do nosso código, enfim, das coisas que a gente está fazendo, às vezes até para compartilhar com um amigo e trabalhar em conjunto, para você não perder, né, a linha do que está sendo feito, e se alguma coisa acontece errado, se recuperar, enfim. E hoje o Bernardo vai falar sobre isso com a gente. Obrigada, Bernardo. Agora é com você.
É isso. Bom, então vamos lá. Posso começar? Sim. Questão da língua. Vocês preferem português, inglês? Como é que a gente faz? Não estou escutando.
Eu acho que não tem ninguém internacional na audiência. Então, se você quiser continuar em português, qualquer coisa, eu te dou um toque, tá bom? Aí
Beleza,
você muda.
então.
Obrigada.
Então vamos lá. Bom, então é isso aí, galera. Valeu pelo convite. Né? Vou tentar contribuir com um pouquinho de Git aqui que eu sei. Então, de forma geral, os objetivos para a sessão de hoje seria, né, ter um entendimento básico de como que o Git funciona. Espero que vocês já tenham instalado o Git, então passar um pouco da configuração inicial e os passos básicos de, né, criar um repositório ou clonar, né, a gente trabalhar com os arquivos e aí selecionar esses arquivos para fazer um commit. E, bom, espero que ao longo dessa sessão a gente, né, vai ter um entendimento melhor dos comandos básicos do Git e também fazer a configuração inicial do GitHub, né? Então, vamos lá. Então, bom, vamos começar aqui com o www, né? O que é, o porquê que surgiu e para quem que isso pode ser importante. Então, o Git é um sistema de controle de versão, né, VCS, como é usado na sigla em inglês, e como o nome já indica, é um sistema para você monitorar mudanças em arquivos ao longo do tempo. E o sistema te oferece, né, a vantagem de você poder detectar o que mudou, quando mudou e quem que realizou a mudança. Né? E é um sistema que também no geral, te permite, né, voltar no tempo. Então, se você quiser restaurar o seu sistema de arquivos para um estado anterior, isso também é possível. Né? E isso é de interesse para vários, né, para basicamente qualquer profissional que queira monitorar essas mudanças ao longo do tempo ou manter, né, de certa forma, várias versões dos seus arquivos. Por exemplo, no site do Git, eles mencionam designers, né? Até lembrei do Alan. Então, às vezes você quer manter várias versões de um desenho, de um gráfico, né? Então o Git te permite fazer isso, além de colaborar em projetos, né, com várias pessoas. Então, bom, que eu sei que muita gente faz, né, e a gente, cientista, faz muito na hora de escrever os artigos, você mantém várias versões de né, basicamente do mesmo arquivo e vai alterando o nome, né, com versão 1, versão 2 ou com a data, né, para manter esse registro no seu computador. Né? Bom, a gente teoricamente funciona, mas não é a melhor solução. Né? É muito fácil de você errar, às vezes você erra o nome da versão ou esquece de colocar, né, um nome novo no arquivo, por exemplo, para marcar que é uma nova versão. Na prática, você tem várias cópias do mesmo arquivo no seu disco, né? E isso também torna a colaboração um pouco mais difícil, né? Porque aí você tem que enviar esse arquivo para todo mundo que for de interesse. Às vezes você pode esquecer de enviar para uma pessoa, e aí, né, no caso, essa pessoa perderia o bonde, digamos assim, né? Então, é nesse contexto que surgem os sistemas de versionamento de arquivos, e hoje em dia, basicamente, seriam duas vertentes, né? Sistemas centralizados ou distribuídos. Então, deixa eu ver se eu só mudo aqui, isso. Então, aqui na esquerda, a gente tem um sistema centralizado, né, onde todo o histórico de versões é mantido num servidor central, e os clientes, né, basicamente, pegam arquivos de interesse desse servidor para trabalhar e depois remetem essas mudanças aqui para o servidor novamente para ficar registrado aqui no histórico de versões, né? É um sistema que funciona, obviamente, porque é usado até hoje, só que o principal contra, né, desse sistema é que você tem um ponto único de falha. Se esse servidor central, por qualquer motivo, sai do ar ou é danificado, você perde todo o seu histórico de versões. E o Git, né, vem como um sistema distribuído, onde você tem esse servidor central para registrar as versões, mas, na verdade, os clientes, todos os clientes, têm uma cópia fidedigna desse histórico. Então, a principal vantagem disso é que, ao contrário do sistema centralizado, se esse servidor cair, todos os outros clientes têm uma cópia, né? Basicamente, cada cliente é um backup, né? Então, você pode restaurar isso de forma muito mais fácil. Então, aqui são alguns links, né, para instalação do Git em diferentes sistemas. Esse primeiro é do site oficial do Git, né, com as instruções de instalação. Foi o link que eu mandei ontem. Se você está usando um sistema Linux, provavelmente você tem o Git no seu repositório de arquivos. Por exemplo, para sistemas Debian, com esse comando você pode instalar o Git. E também tem aqui esses dois links para versões direcionadas para o sistema Windows. E aqui é o link para você, caso você não tenha uma conta no GitHub, você se inscrever. Então, vamos lá. Estou supondo que esses passos já foram realizados. Qualquer coisa, é só vocês avisarem. Bom, logo depois de instalar o Git, basicamente, o que a gente tem que fazer é uma configuração inicial. E essa configuração é feita com esse comando aqui, git config, essa flag de global, para você implementar essas mudanças para todo o sistema. E aí depois você tem uma chave e um valor. Basicamente, os principais agora seriam o nome de usuário, né? No caso, o seu usuário do GitHub, e também o e-mail, né? Que também tem que ser o e-mail da sua conta do GitHub. E muita gente também gosta de configurar o editor de texto, né? Isso é meio que opcional, porque se esse valor não for configurado, o Git usa o editor de texto padrão do seu sistema, né? Mas muita gente, às vezes, usa algum editor de texto e pode fazer essa configuração aqui. Por exemplo, no site do Git, a gente vê essa recomendação para o sistema Windows, caso você queira usar algum outro editor de texto. Nesse caso aqui é o Notepad++. Então, esse seria o comando para você configurar essa variável aqui, né? Para sistemas Windows, ele diz que você tem que passar, né, todo o endereço do executável do editor de texto que você quer usar. E caso você queira conferir quais variáveis você já tem ajustadas no seu sistema, esse aqui é o comando, git config l, -l ou -list, né? E aqui, como eu disse, com essa flag aqui de global, essas configurações ficam gravadas para todo o sistema, porque o Git também te permite fazer configurações individuais para cada repositório que você tem. Então, imagina que para um projeto, esse projeto está hospedado no GitHub e você tem um certo usuário, e pode ser que um outro projeto esteja hospedado no GitLab, por exemplo, e lá você tem um outro usuário. Então, você pode ajustar essa configuração de acordo. E também a saída, o output desse comando aqui pode variar de acordo com o diretório no qual você se encontra. Então, se você está em um diretório que tem, por exemplo, 10 variáveis configuradas, ele vai te mostrar essas 10. Mas se você tiver num outro diretório com uma configuração mais simples, pode ser que ele só te mostre 2 ou 3 variáveis.
Oi,
bom, então,
Bernardo.
basicamente...
Desculpa interromper aqui, o Jonathan perguntou como ele pode configurar usando o token.
No caso, desculpa, configurar qual variável? Porque essas configurações aqui são basicamente as que você vai precisar para você realizar um commit, para você enviar, né? Nem para enviar, para realizar um commit, porque em todo commit tem que ter quem realizou, né? No caso o nome, o e-mail. Então, o token, eu até tentei olhar isso ontem e no momento não consegui achar, mas o que eu sei é que tokens são mais usados, por exemplo, quando você quer dar, se você quiser, por exemplo, dar acesso a uma aplicação que você desenvolveu, você quer dar acesso, né, você quer permitir que essa aplicação acesse a sua conta do GitHub. Então, no caso, você utilizaria um token, né? Essas configurações aqui iniciais não envolvem qualquer tipo de token ou chave de SSH ou coisa do tipo. São configurações para você poder realizar os commits. Não sei se eu consegui responder. Mas eu, mais para frente um pouquinho, eu vou comentar dessas chaves de autenticação, mas basicamente o que é usado, o principal é a chave SSH, né? Mas aí daqui a pouco a gente comenta sobre isso. Mais alguma dúvida com relação a isso? Então vamos lá. Então, basicamente, existem duas formas de você iniciar um repositório Git, né? A primeira delas, ou talvez a mais simples, seja com o comando git init. Então, esse comando ele vai tornar, basicamente, o seu diretório local, né, o diretório onde você se encontra, em um repositório Git. Então, a partir daquele momento, o Git vai começar a monitorar aquele diretório para criar o histórico de versões. E uma outra forma é você clonar algum repositório online, né? Então, por exemplo, lá no nosso Git do CSBL existem vários repositórios, né, de diferentes projetos. Então, lá tem sempre um endereço que te permite clonar aquele repositório. Então, com o Git init, basicamente, você começa do zero, né? Você pega um diretório local e diz para o Git que você quer monitorá-lo, e a partir daquele momento ele vai começar a criar o histórico de versões. A partir, né, enquanto que com o Git clone, você está basicamente copiando um repositório que já existe online, e com isso você também vai copiar todo o histórico de versões já armazenadas ali. Então, isso aqui é para a gente ter uma visão geral de como que o Git funciona. Então, por exemplo, quando a gente dá um git init, a gente começa aqui, né? Você disse para o Git que você quer monitorar aquele diretório, mas ele não sabe, por exemplo, quais arquivos você quer monitorar. Então, nesse momento, né, você tem um repositório, mas todos os arquivos ali estão nesse estado aqui de untracked, né, não estão sendo monitorados. Ao passo que, por exemplo, com o Git Clone, você começaria aqui. Né? Você copiou o repositório online, você ainda não modificou nenhum arquivo, né? Então ele se encontra no estado de não modificado, mas você já tem todo ali um histórico de mudanças e o Git já sabe quais arquivos monitorar ou não. Quando você, né, edita algum arquivo, ele vem para esse estado de modificado. Né? E você pode escolher monitorar um arquivo modificado ou não, você pode escolher, quer dizer, no caso do arquivo modificado, ele já está sendo, né, monitorado pelo Git. Mas você pode escolher, por exemplo, incluir esse arquivo num commit ou não. E aí que vem, né, a questão de a gente sempre tem que falar explicitamente para o Git que a gente quer incluir um arquivo modificado em um commit. Então você faz isso com um comando que eu já vou mostrar, que é o Git Add, e isso basicamente pega o arquivo do estado modificado e leva para esse último estado aqui, staged. Né? Então a gente na documentação do Git vê muito esse termo staged, então é como se fosse mesmo não um stage, um palco, né? E ali é onde você põe tudo, você, né, explicitamente fala para o Git, eu quero incluir todas essas mudanças, todos esses arquivos no meu próximo commit, né, para entrar no histórico de versões. Então, vamos lá. Vamos, né, agora brincar um pouquinho no terminal, na linha de comando. Então, por exemplo, para a gente iniciar um repositório com o Git init. Né? Então, por exemplo, aqui eu vou criar um diretório chamado Lab Training Git, vou entrar nesse diretório e aí vou dizer para o Git, olha, eu quero ter um controle de versão nessa pasta local aqui. Né? Então, se eu for aqui, ó, eu já até tenho esse diretório, mas eu vou removê-lo. Então, vamos lá. Então, seguindo, ó, eu crio o diretório. E esses passos, se vocês quiserem, vocês podem ir acompanhando aí, seguindo também, tá? Na máquina de vocês. Então, eu criei o diretório. E agora eu estou ali dentro, né? No momento, dá para ver, eu não tenho nenhum arquivo, acabei de criar o diretório, mas de qualquer maneira eu já posso dizer para o Git que eu quero monitorar essa pasta. Então, por exemplo, dou um git init. E aí, como eu enfatizei aqui, né, essa é a mensagem que a gente recebe, que ele iniciou um repositório que ainda está vazio na sua pasta local e ele te mostra, né, o endereço. A gente pode ver aqui, ó, dessa pasta, uma pasta oculta, né, .git. Então, basicamente, é essa pasta que torna o diretório em um repositório. Né? Então, aqui é nessa pasta que o Git armazena todos os dados para monitorar. Né? Então, isso aqui também é interessante, porque, basicamente, se você quiser deixar de monitorar uma pasta, você não quer mais que ela seja um repositório, basicamente, o que você tem que fazer é remover essa pasta e pronto, digamos, volta a ser um diretório normal. Né? Então, beleza. Então, iniciamos
Bernardo,
aqui. Oi.
eu sei que você não está conseguindo ver por conta que você tem que ficar trocando de tela, então eu vou ficar interrompendo de vez em quando, tá?
À vontade, claro.
O Tomás perguntou se você consegue dar zoom no terminal.
Posso tentar, porque eu nunca
Also,
fiz isso.
Yuvka is watching, if you can switch to English.
Okay, so let's do that. Oh my god. Aí, consegui. Is it okay now? hope so. Okay, so then we've just started the Git repo in this directory. So now let's just create our first file, and we can do that, for example, with the famous hello world. And so now we have a first file. And one of the commands that you use most often is Git Status. So I think the name is kind of self-explanatory. You know, it gives the status or the current status of your repo. And here we see on branch master, no commits yet. So we've just started the repository. So there are no commits yet. But here we see untracked files. So it sees this file, but Git is not monitoring it yet. And it already gives us a hint here that, you know, nothing added to commit, but untracked files present. Use Git Add To Track. So that's what we'll do next. Git add and file name. And if we hit Git status again, now we see new file, hello.txt. So from now on, well, actually, this is just telling Git that, you know, I want to include this file in my next commit. So yeah, as I mentioned, this what this does is this puts the file on the stage for committing. So Git add file name, and it actually can be file names. So if you want to add multiple files at once, you just type file name 1 space file name 2 and so on, and Git will stage all those files for the next commit. Okay, so now let's say we're happy with this. You know, we want to basically write this record in the version history. So we do that with the Git commit, and so it's basically a requirement from Git that, you know, in every commit you have to write a message explaining what the commit is doing. You know, you're updating a file, you're deleting it. You know, you've created a new file and so on. So this message is compulsory. And you can explicitly write the message with git commit -m and you write your message. Or if you omit the message and you just type git commit, it will invoke your text editor. So that's where that configuration core.editor comes in. You know, if you don't explicitly type the message, your text editor will pop up, and then you have to write the message, you save it, and then Git goes on with the commit. So let's do that now. So let's say Git commit, and I prefer to always, you know, explicitly write the message. So usually people would say something like initial commit, and for example, add hello.txt. And now this change, you know, it's written in the version history. And if we go back to now Git status again, so, you know, everything is clean. I haven't modified any file. I haven't created any file since my last commit. So as it says here in Git terminology, the working tree is clean. And another useful command that we use a lot is Git Log. And this basically shows all the history of the commits. So far I have only one commit. And here we see the author, the name, the email, the date, and the commit message here. And so another way, for example, to create a commit, as I mentioned previously, usually we use Git Add, to stage all the files that we want to include in the next commit. But let's say that you want to include all the files that you have edited. So a shortcut for that is Git Commit -A. So this will put all the files that are being monitored into the staging area for the next commit. So in this case, you don't have to write Git add and all the file names. It does it automatically for you. So it stages all the file. And you can also, use a compound flag here with -A. So you can write commit -am. M is for the message, as we see up here. And then you write your commit message, and then everything goes in one line of command, so to speak. So far, so good. So Git also has let's say, its own version of some of the shell commands. So, for example, on Unix systems, and I guess also in the PowerShell in Windows systems, you can use the rm command to delete a file. But if we do that in a Git directory, Git will see it as I think unstaged changes. So, for example, if we go back here, we have the hello.txt file, and from our status, we see that everything is clean. But for example, let me just move this file to the upper directory. And now if we try Git status again, so it sees the file as deleted, and these changes are not staged for commit. Okay, so then we would have to basically fire, a couple of commands to basically write this change to the version history. Whereas, for example, if I get the file here again, so now it's back, and if we check the status, everything is clean again. But for example, suppose I want to remove this file, then I can use git rm hello. It removes, or it basically stages the file for removal. And if we check git status, it's automatically staged for committing. And if I really want to remove the file, basically I just have to commit the change and write a message, for example, delete hello.txt. Now the change is committed, and I no longer have the file in my directory. Okay, so this is just a shorthand command if you want to remove files, and the same thing goes if you want to move a file. Instead of just moving it, and then the changes will be unstaged and so on, you can just use git move if you want to move the file to another location, or just rename it. This is also the command for renaming files. Okay, so so ignoring files. So suppose there are files or directories in your disk that you don't want to version control. So there's also a hidden file that's called .git ignore, and in there you can put everything that's in your local repo, but that you don't want to version control, because depending on how many files you have, the unmonitored files, when you for example, if we create again the hello file, So all the untracked files, they always, when you hit Git Status, they always appear here in untracked files. And depending on how many files, the list can be quite long, and you don't want to see, all those names. They may even like clutter your whole screen, so you don't want to see that all the time. So you might as well just put all those file names in the .git ignore file. And the nice thing is that it accepts shell patterns. So, for example, people that work with C code, you have to compile the code, and there are a lot of intermediary files with the extensions .o or .a. So you can, just write this. It's basically a regular expression saying that I don't want to monitor any .o or .a files, and you put that in Git Ignore, and those files will not appear as untracked changes anymore. And you can do that basically for, you can create different patterns for the files that you don't want to version control. So yeah, Git Diff. So this is also a nice command. So I think the diff command is already standard on Unix systems, and it basically shows you differences in files. What has changed in the files. So if we go back here to the command line, and let's say that we add the hello again, and we commit the change. For example, so Git Status, and everything is clean. But let's say we're gonna edit this hello file. So for example, we go here and we edit it. And now we see that we have a modified file. And now we can use, for example, Git. Is that it? Yeah, Git Diff. Isn't it? Sorry. It's without the dash, I guess. Yes. So this is gonna show us all the changes that we have made to the files that we haven't staged yet for committing. So here we see, let's say the original file, we only had hello world, and now we have, the new file with the addition. And so, as it's written here, Git Diff, we only show you the unstaged changes. So if I happen to already Git add hello.txt, and if I try the same thing again, it will show me nothing, because the change is already staged for committing. And in that case, if I want to see staged changes, I can use this second command here. It's just Git Diff again, but with the flag staged. And then it shows me the same output again. So this is just a way to check if you really want to commit the changes, to see what changed in the files. And if you want to go ahead with the commit, then you just proceed with it. And okay, so then we can, for example, commit again, message. And it's also, I think, common practice, let's say, to write the commit messages as short as possible, and usually in this style that you start with a verb, for example, update a file, create, delete, and so on. And Git status again, and everything is clean. And for example, now that we have made a few changes, if we go to Git Log, then we have now a longer version history with all the changes that we made. And these are the hash here in yellow. These are the hash values, basically the identifiers of the commit. And well, there's also another version of this command, because here we have a lot of detail. You know, the authors, the date, the commit message, the hash, and so on. So if you want like a summary of this log, you can also use Git Log, and with the flag, one line. And now we have, yeah, a much nicer view with the initial digits of the hash and the commit message, basically.
Bernardo,
Oi.
we have a question. Frederico asked, the changes are automatically uploaded to your Git account in the cloud?
No. So this is something that's coming. We're gonna do with the SSH key. So far, everything that we're doing is local. You know, everything is recorded in our computer. Basically, this is the local version of the repository. So we haven't uploaded anything to GitHub, for example, yet. You know, and this is one nice thing with Git. So I guess, for example, with the centralized systems, you have I would say a greater dependency of being online all the time, because, you know, if you want to write the version history, you have to write to the central server. So if you're not online, you cannot do that. Whereas with Git, you know, you can do as many commits as you want locally, and then, you know, by the end, when you're done, you can push everything to the cloud, so to speak, to GitHub, for example. But so far, everything that we have done is just local on our own computer. And okay. So yes, I'm doing things with a little help from Git Status. So hopefully this is something we won't have to do often, you know, revert changes. But for example, let's go with the hello file again. And let's say I edit it. Let's go back to the hello world. And if we hit Git Status, so change is not staged for commit. So it sees that the file has been modified. And here it gives us a couple of hints. So we can add the file to stage it for the next commit. But more importantly here, for now, if you want to discard the changes, you can write git restore and file name. So if we check the contents, it says hello world. And let's try that now. Git restore hello.txt, and hopefully we have the old file again. So this is, if you edit a file and you just don't want to keep the changes, you can basically restore it to the version that's recorded in the Git history. And so this discards an unstaged change. But let's go and try the second one. So we save it. Once again, Git status, modified, but let's say that we have added it. And once again, with Git status, we get another hint. For example, use git restore staged and file name to unstage it. So let's try that now. Staged and hello. And if we hit Git status again, we see that it's unstaged but modified. And this is, you can use, for example, if you have staged a file for committing, but you remember that you have to, edit it again, add a line, delete something, then you can unstage it, modify it again, and then add it for commit again. And another one that I actually found helpful, especially in the beginning, to me at least, it happened a lot that I would commit the changes, but then I would remember, okay, I forgot to add this file or that file, and in that case you can use Git Commit Amend. And for example, if you forget to add some files. And this is, I guess, one of the few times where this command, usually in Git, you only add to the version history. So even if you want to restore something to a previous state, in general, what Git does is it creates a new commit, reverting things back so that everything is recorded in the history. But with Git commit -- amend, what it does, it basically overrides your previous commit. So it's as if it never happened. So that's something to keep in mind. And here, if you just type Git Commit Amend without any explicit message, once again, your text editor will pop up. But this time it will have already the previous commit message written. So if you want to keep it, you just save it and keep it. Otherwise, you can update the commit message and go on with the committing again. Yes, so, well, hopefully you guys already have an idea of what an SSH key is. And this is the way that, for example, GitHub is authenticating users now. So previously, when you wanted to push, as Federico asked, when you want to push your changes or your commits to the cloud, to GitHub, for example, you could authenticate with a username and password. But this is now deemed a bit insecure, and so the authentication method now is with the SSH keys. And here are a couple of links on how to do that, how to create an SSH key, how to add it to your key manager, and later on we have to basically upload the key to GitHub so that the authentication goes through smoothly. So the first thing to do would be to check if you already have an SSH key. And usually the default location for the key files is this one. So the home directory, and then you have a hidden directory .ssh. And so you can list the contents of this directory. For example, I should have some keys set up here. So .ssh. And here we can see that I have a couple of keys. So this is kind of critical. So the key that you're going to upload to GitHub is a public key. So it's the file name with the .pub extension. So never upload this one. This is your private key that's used for decryption. So it's always the .pub file. And so also the default name for SSH keys is ID _ and the key type. So in this case, I think it's still widely used, the RSA algorithm for key creation. So as we can see here, ID _ RSA and the RSA.pub here. So this is the file that we have to upload to GitHub, for example. So in the case that you don't have any SSH key, this is the command that you use to generate the keys. So the ssh.keygen. So is there anyone that doesn't have an SSH key that you have to generate it? Because I think I have the so in any case, once we have the SSH key, so you on your GitHub profile, your GitHub page, you go to your settings panel. So here you click on this icon here on the upper right, and then settings down here, and here under access we have SSH and GPG keys. So if we click there, then you come to your SSH keys and GPG keys. So as you can see here, I have a few different keys. So for example, this one is from this computer I'm working on. I have another one for the laptop, another one for an online course, and so on. So basically what you do, you come to, if you want to add an SSH key, we get here new SSH key, and then you give it a title to identify it. So like I did here, I have one for my desktop, one for the laptop. You may have one for example, the CSBL notebook you're working on. So you write basically an identifier here as a title, and then you copy the contents of the public key and you just paste it here. And then you can add the SSH key. So is everybody up to date with that? Does anyone have to generate a key? Because in that case, we can go back to this link here to go step by step. So yeah, just to quickly go through it. So basically, if you have, and yeah, let's leave it on Windows system. That's what most people use. So on the command line, you go to SSH keygen, and here, for example, whereas I have the RSA algorithm, here they use another one, so you can specify the key type that you want. But basically what you do is SSH keygen, and then you use your email as the identifier for that key. And this, once again, has to be the email that you use for your GitHub account. And so, as I mentioned, this is the default location, your user directory. So on Windows C, users, your username, and then .ssh and ID underscore and the key type. And also, if you want, you can add an extra layer of security. You can protect your key with another password, a passphrase. But I guess what most people do is they just leave it empty. So when it asks for a passphrase, you just type enter and you leave it without a password. And then here it lists the steps to add the SSH key to this SSH agent. But okay, I'm assuming that we are on track with that. Yeah, so here's the same thing. And yeah, and this is also what I mentioned. So you can, I guess this is also Windows based, you can use this command to copy your public key to the clipboard, and then you go to that SSH page under your settings to add the SSH key. Yes, so for example, so far, everything that we have done here, as I mentioned, is local. We haven't pushed anything to GitHub yet. And this, let's say, this cloud server under Git terminology, it's called a remote. So it's, yeah, you can think of it as a remote server, for example. And you can list your remotes with the command git remote. And as we can see here, there's no output, which means that we haven't configured, we haven't added any remote address that we can push our changes to. So that has to be done on your GitHub page. So basically, let's go here to the initial screen, and let me, yeah. So here on the left menu, we already have this button here, new, recent repositories, new. And so we can create a new repository. And I'll give it the same name as the folder, so lab training Git. And if you want, you can add a description. It's optional. You can choose if it's public or private. We're gonna leave it public. And you can already, for example, add a README file, which is quite common. Basically, in a README file, you give, description of your repository, instructions for people to use the code, and so on. There's also the Git Ignore file. You can choose a license for your repo, and so on. But basically, let's just go ahead and create the repository. So now it's basically created. And here, for example, we can choose between the HTTPS, a protocol, or the SSH. So as we have set up our SSH keys, we can go on with that. And here Git gives us, or GitHub gives us a couple of options. You can create a new repository on the command line, but we have already done that with Git init, or we can push an existing repository from the command line. And here are the commands that we need. So here we can see Git Remote Add, origin, and an address. So basically the syntax for this command is Git Remote Add, and this is the name that you give it to this remote. So this is like a short name or a nickname, So this whole address here can from now on be referenced with the name origin. So instead of typing this whole thing, we can just type origin. So let's go and do that. Yeah, let's just copy the whole thing, I guess. And so yes, let's. Okay, so now we have actually pushed all those changes, all those additions, deletions to the files. Now we have pushed everything to the cloud, so to speak, as Fred asked. So if we go back here and to code, now we can actually see that we have our file on our remote repository. And if we go back to the command line, and now if I type git remote, now I see an output, origin, which is the nickname we gave it up here. Git Remote Add origin, and then the web address. And if you want to see the whole thing, if I remember correctly, I think you can use Git Remote -v, and now we see origin, and then beside it the whole web address that we are pushing to. And here we see fetch and push. So fetch is where we get our code from, and push is where we submit the changes to. So I've never worked with that, but I think you can have different addresses. So if you want, for example, to fetch the data from someone else's repo, and you want to push the changes to your own repository, so then you would have different addresses here for fetch and push. But in this case, it's the same, and they're both under the nickname origin. And now if we hit, for example, Git Status, yeah, so we haven't committed this change yet. So let's see the state of the file, and if we go Git commit, the message, let's say update hello.txt. Oh, sorry. First I have to add the file. Hello, Git status, it's modified, and now we can do that. And now we can once again use that. So when you want to submit your changes in Git terminology, they say Git, you want to push your changes to remote. So it's Git push, and here I think it's, so the syntax is Git push the remote that you want to push to. In our case, it's origin, and then the branch that we want to push. So if we see here from Git status, we see that we are on branch main. So that's the default name that the Git gives to a branch when you start a repository. You can change that, but that's the most common name. So here it's Git push, our remote, which we named origin, and then the branch that we want to push to remote. And we do that, and hopefully, yes. So now those changes are, so we see the commit message was the same, but hopefully the time delta here will change. So if we refresh this page, and now we can see 2 minutes ago, it pushed the changes to the remote repository. So I think this was actually the last slide. Yes. Yes. So this is what I had in mind for today. Hopefully it wasn't too confusing. But if you have any questions, comments, issues, we can try to discuss them now.
I have a question.
Yes.
If I deleted one file and commit this change, but now I have a wish of restore this file. Can I do that?
So if you deleted the file and you committed the change, yes, you can do that, but I would say that's a bit of a more, let's say, intermediate advanced topic, which I thought of, if you guys want, we can, have another session to talk about these other topics, such as branches, merging, and restoring files. So basically, as I mentioned, Git allows you to travel back in time. So if we check here, Git Log, for example, and let's see, 1030, yeah. So up here, it's the most recent ones, and then it goes back in time. So basically, you see these commit hashes here. So you can go back to any of these previous states, and what you need is the hash of the commit that you can easily get with Git Log. So I'm not sure if the command is git restore or git reset, but yes, you can do that. That's one of the benefits of Git, so to speak. But it's as I mentioned, hopefully we won't have to do that often, because it's it can be tricky to do so, and especially, for example, if I think in Git they call it you can do a soft reset or a hard reset. So in a soft reset, basically, so once again we have, if we check here, we have this ahead term here, and this is the last commit, so it's the most recent one. So basically, this is a pointer. So this head pointer is it's pointing to main, to this last commit. So in a soft reset, for example, you can move the head to a previous commit. So let's say I want to go back to this state here. Then you move head to this previous state, and then Git will basically bring this snapshot of your files in this state here as the current one. But you can also do a hard reset, and then basically you modify all the files back to previous state. So with the soft one, you move the head down here, but let's say basically you have the option of moving the head back to this guy. And with a hard reset, it's basically you overwrite things. So it will be a bit more tricky.
It's similar to commit amend.
Yeah, I think so. Yeah, if you do a hard reset, I think the hard reset it's mostly problematic. For example, if you're working on a project with a lot of people, and then so basically you have a lot of people taking the code from your repository. So if you do a hard reset, you may make life very difficult for the other people collaborating on the project, because then they may have changes that they haven't committed yet, and they try to. So, for example, if you do a hard reset and you delete a file, but someone else is working on that file, and they try to push the file to commit, then you're going to have a lot of conflicts. So, summarizing, yes, you can do it, but it's a more of an intermediate advanced topic, because it can create trouble for people.
So can we schedule a lecture for Git Advanced?
Yes, absolutely. Because there are a lot of things that we haven't covered. So, for example, restoring or resetting branches. So branches are a really nice feature that basically you can do experiments. So yeah, I was trying to think of a bioinformatics example. I don't know, but for example, if you're doing a RNA-seq analysis and you want to experiment with some parameters, I'm going to try to run this analysis with a different configuration. but you don't know if it's going to work or not. But you have all the data files, everything you need in the same directory, of course. So you can create a different branch. So as I showed here, this is the only branch that we have, main. But let's say I want to, I can create a different branch for this alternative analysis, and then you can perform your analysis without interfering with your main workflow, so to speak. And if the analysis works, if the experiment works, then you can choose, okay, I'm going to go ahead with this alternative analysis, and then basically you can merge, this alternative branch to the main one, and from now on you work with the alternative analysis that you were running.
Spoilers to the next training. So Frederico asked if the video will be available. Yes, in fact, it is already there, so you can watch again when you want. And Mauro made a comment, Git is like a time machine. Yes. Very useful.
Yes. That's a very, very nice feature that it's kind of you always have a backup of all your analysis and even data. You can submit data files to the repositories as well. So you kind of always have a backup. And yeah, like we mentioned, if you screw something up or you can just go back to a previous state and continue from there on.
So thank you very much, Bernardo. We are
you,
already past 10 minutes of your time, but it was very interesting. I did my first push today. So in the next
congrats on that.
And then next day we can schedule a more advanced use of Git, but for now it was awesome already.
Yeah, and if you guys have any questions, you can just write at any time. It's as simple as that.
Okay, thank you very much. Bye bye, guys.
Bye bye.